Page 2 of the Unit 2 test review. So let's see here. This page covers section 2.2. All right, they want us to find the exact value. So exact, no decimals. All right. The value of all 6 trig functions given the information in the problem. All right. Now, they need to be simplified. So you should always reduce your fractions. All right. Rationalize. That means no square roots on the bottom and reduce, which I already said. Reduce your fractions. So simplified means breaking down square roots. So what I mean by that is like the square root of 20 equals 2, square root of 5, stuff like that. All right, so that is the goal for this one here. So when we were plotting our points, right, the coordinate point, 5, -4, that's going to be on the x and on the y. So that tells us we are going 5 units to the right. Right? And we are going 4 units down. All right, so I'm going to take that 5, I'll put it on the outside of the triangle. So we need to make a triangle out of this. All right, this is, of course, a right triangle. X-axis and y-axis are perpendicular. What we need to do is we need to find, we call this the radius. All right, so we're not calling that like C anymore. We're going to call that the radius. All right, so to figure out the radius, all we have to do is Pythagorean theorem, r squared equals -4 squared plus 5 squared. Right? What is that going to give us? Keep in mind, this number right here, this -4 squared, should be a positive number. Anytime you square a number, it turns into a positive, right? So this should be 16 plus 25. Oh, what is that, 41? So we know r squared is 41. Therefore, r is just the square root of 41. So now you should always try to reduce those radicals, but this one does not reduce in this case. All right, so we're going to call this the square root of 41. All right, now it's just a matter of filling out our 6 trig ratios. So let's kind of keep in mind we have this SOHCAHTOA idea. Right, so we know sine is equal to the opposite over the hypotenuse. We are going to use the reference angle on these things. Whenever I'm talking about the opposite, the adjacent, the hypotenuse, always talk about, we're always using the reference angle to kind of guide us here. So if we look here, sine is opposite over hypotenuse. The opposite here is -4. The hypotenuse is the square root of 41. All right, so that's what the fraction looks like. However, they want us to rationalize it. So let's move that square root of 41 to the top. We got -4 over the square root of 41 all over 41. Right, that's our fraction rationalized. Try to reduce it if you can. This one will not reduce. Right, now the cosecant is the reciprocal of sine. All right, so I'm just going to look at that original one and I'm going to flip it upside down. Get square root of 41 over -4. And that one's done, right? It's reduced, it's rationalized, it's simplified, nothing else we need to do on that one. Right? The next one is the cosine. The cosine goes with the adjacent over the hypotenuse. So 5 over the square root of 41. But again, we need to fix it. So I'm going to call that 5 radical 41 over a normal 41. And then the secant is the reciprocal of cosine. So again, take that original one and flip it upside down. And there we have it. And then the tangent, opposite over adjacent. So this one's the easiest one, -4 over 5. Don't have to fix it, don't have to reduce it. That one's good to go. Flip it upside down to get the cotangent. That's 5 over -4. Right? And that one's done. That's all there is to it. All right. On the next one here, let's see here. X is 1, but it's a positive 1, so it's going to go in the positive direction. The y value is the square root of 11. I have no clue what that is. It's a little bit bigger than 3. And we need to figure out, let's do this in a different color. We need to figure out this radius here. All right, so same process. as before. We got 1 squared plus the square root of 11 squared equals r squared. So 1 squared is 1. The square root of 11 squared is just 11. All right, a square and square root knock each other out. Equals r squared. 12 equals r squared. Square root both sides. You're going to have the square root of 12 equals r. Now, this is where the reduced part comes in. This is square root of 4 times the square root of 3, which gives us 2 square root of 3. That is our radius in this case. All right. So now let's go ahead and fill everything out again. Remember, we're using our reference angle. So the opposite here is square root of 11. Square root of 11 over 2 square root of 3. Right? Not rationalized, unfortunately. So let's go ahead and do that. We're going to call this the square root of 33 on top, all over 6. All right, now how did I get that? Let's do some side work over here. All right, the whole reason this is bad is we have that radical 3 on bottom. So multiply the square root of 3 on top and on bottom. Root 11 times root 3, square root of 33. All right, square root of 3 is regular 3. 2 times regular 3 is a normal 6. All right, so that's how I got radical 33 over 6. Now, flip the original upside down. We're going to have 2. The color's the same here. 2 square root of 3 over the square root of 11. That's going to give us 2 radical 33 over 11. And that one's done. Cosine the adjacent over the hypotenuse. All right, so fixing that, we're going to get square root of 3 over 6. And then the secant, luckily, that's why you look at the original one, because if we flip the original one upside down, we don't have to do anything with it, right? That one's already done. It's reduced, simplified, and more importantly, rationalized. All right, then the tangent is the square root of 11, opposite over adjacent. That one's fixed. It's done. Good to go. Cotangent 1 over square root of 11. Fixing that gives us radical 11 over a normal 11. All right. Let's see here. Draw a triangle, find the exact value. So if the cosine is equal to 1/3 and the terminal side of theta lies in quadrant 4, they want us to find the tangent. All right, so there's a lot going on here. So let's just go ahead and make a graph. So they're saying the cosine is 1/3. So remember, cosine is equal to the adjacent over the hypotenuse. They're telling us the terminal side is in quadrant 4. So let's use that. So drawing our angle in standard position, terminal side ends somewhere down here. I don't know where it ends down here, but what we can do is we can make a triangle out of this. We know our reference angle. So that's where we have to kind of label our sides. So if the cosine of theta is 1/3, that tells us the adjacent side is equal to 1. The hypotenuse is equal to 3. All right, so let's fill it out accordingly. You have 1, you have a 3. We need to figure out this value here. And how do we do that? Just how we've always been doing Pythagorean theorem. So we have 1 squared plus y squared equals 3 squared. Keep in mind the hypotenuse and these things always have to be on its own side of the equation. So we got 1 plus y squared equals 9. Y squared equals 8. Therefore, y equals the square root of 8, which of course simplifies into 2 square root of 2. They're asking us to find the tangent now of theta. So just recall the tangent is equal to the opposite over the adjacent. we just found the opposite, right? The opposite was 2 square root of 2. So the tangent of theta is equal to 2 square root of 2 over 1. Right? That's our opposite over the adjacent side. Right? So same thing here. Sine is, let's see here, need another graph. Sine is equal to -2/7. Right? And the terminal side of theta lies in quadrant 3. All right, so here's our initial side. Terminal side is somewhere down here. We don't really know where it is, but we can make a triangle out of it. Fill in our theta. Right, let's see here. We know sine is -2/7. So sine is equal to the opposite over the hypotenuse. One thing to keep in mind is on these, I haven't mentioned it before, but the hypotenuse, or we're calling it the radius on these things, is always going to be a positive number. So this sine of theta is -2/7. Well, the 7 has to be the hypotenuse. The 7 is the positive number. And the opposite, the negative sign has to go somewhere, so the opposite is going to be the negative. And if you just kind of think about where that is on a graph, that should make sense, right? It's going down 2 spaces. So since it's going down 2 spaces, it has to be a -2. Our goal is to figure out this side here. And again, same as before. X squared plus -2 squared equals 7 squared. So x squared plus 4 equals 49. X squared equals 45. X equals the square root of 45, which if we simplify that, we're going to get 3 radical 5. All right. They are looking for the secant. Right. So secant is the reciprocal of cosine. All right, I don't have a lot of the other 3 memorized, but I have the original 3. So the cosine is the adjacent over the hypotenuse. All right, so that means the secant is equal to the hypotenuse over the adjacent. All right, so let's just fill it in accordingly. We know the secant of theta of our reference angle equals the hypotenuse, which is 7/3 square root of 5. Let's go ahead and simplify that, and we're going to have 7 radical 5 over 15. And there we have it. That is page 2 of your test review. And again, this covered section 2.2 in your notes and in your homework. All right, so we'll see you guys for part 3.